Our first example for finding the domain is 3x Wow, not working well here. Let's try again. 3x minus 3 divided by x squared minus 1. We need to know where the denominator will equal 0 because we're not allowed to divide by 0. So I make an equation that says x squared minus 1 equals 0. And I solve this. So I add 1 to both sides, so I get x squared equals 1. I take the square root on both sides, and I get x equals positive or negative 1. So this is my domain restrictions. So technically x cannot equal positive or negative 1. So my domain is from negative infinity, which always uses the parenthesis, up to negative 1, uses the parenthesis because it can't equal that, union, negative 1, up to positive 1, and again parentheses because it cannot equal negative 1 or positive 1, and then union, the interval from 1 up to infinity. So let's try another one. Our second example, our function is x plus 2 divided by 2x plus 10. So because we're looking for the domain, we know we cannot divide by 0. So we're going to have an error or an undefined when 2x plus 10 equals 0. So I write that equation and I solve it. So 2x equals negative 10. Divide by 2, x equals negative 5. Now again, this is actually what x cannot equal. So our domain is everything else. So our domain goes from negative infinity up to negative 5. Does not include negative 5, so I use the parenthesis. And then a union from negative 5 up to infinity. So now it's going to be your turn, and I'd like you to work through 2 more examples where you find the domain for the rational function.